Alright, welcome back everybody. In this video we're going to talk about graphing polar coordinates and look at the first couple of examples from this lesson. First of all, you should recognize the notation for a polar ordered pair. When we see a polar ordered pair, it's got two components, and instead of an x and a y, what we have is an r, which is the radius, the directed distance from the origin to the point, and then we have a theta component, which is the directed angle from the initial ray, which is usually the positive x-axis. So if we fix an origin and initial ray, every point we have can be represented by an ordered pair r theta. It talks here a little bit about polar coordinates not being unique and how some points can be represented, well, all points can be represented with multiple polar coordinates. You can read through that at your leisure. Now we're going to start with a basic analog to some ideas that we know from Cartesian coordinates. You should be familiar with the fact that whenever you see something of the form x equals a in a Cartesian coordinate, it produces a vertical line. And whenever you see something of the form y equals b, it produces a horizontal line. We have similar relationships that exist with polar equations. If we see r equals a, what we have is we have a circle with a radius of absolute value of a. So if we have r equals -4, it's going to be a circle with radius 4, centered at the pole. Similarly, if we have an equation of the form theta equals some angle alpha, that's going to be a line through the origin that makes an angle of alpha with the initial ray. Alright, let's look at example 1. We're going to write an equation for the graph of the functions shown below. Okay, we have a line in this first one, a line through the origin, and so this is going to be an equation of the form theta equals alpha, and now we just need to figure out what this angle is. And if you go and measure what this angle is, you see that this angle is an angle of pi over 3 units. And so the equation for this graph is just going to be theta equals pi over 3. Okay. In the next one we have a circle. And so we need to figure out, this is going to be an equation of the form r equals something. And we need to figure out what the radius is from the pole to this circle. And it's 1, 2, 3, 4 units. So there are actually two equations we can write here that represent this circle. We could write r equals 4. Or the other common one would be r equals -4. By the way, there were actually an infinite number of equations that I could have written for this first one. We could have written theta equals pi over 3. If we count around, that's also theta equals 4 pi over 3. Or 7 pi over 3, or 10 pi over 3. You know, there are literally an infinite number of equations that we can write for that. I normally try and keep it simple and stay with the most basic one, which is why I chose theta equals pi over 3. Alright, in this next example we're going to graph some sets of points. Alright, so we're first going to graph the set of points where the radius is between 1 and 2 and the angle is between theta and pi over 2. So we've got the angle between here and here and the radius between 1 and 2. And so any point in this region meets those specifications. The radius is between 1 and 2, and the angle is between 0 and pi over 2, and we end up with that little macaroni almost shape. Alright, next. Radius is between -3 and 2, and the angle is pi over 4. So an angle of pi over 4, that's on this spindle right here. And so we're going to draw all the points that are on that line through the pole that have a radius of between 2 and -3. So we start out here at -3. and draw the line through the origin up here to 2. That's a pretty bad line. How about I use my line tool? We'll see if I can do a little better. Of course not. I missed. Let's try that one more time. And it moved a little bit on me, but I think you get the idea. Alright, continuing on to part C. The radius is less than or equal to 0, and theta is equal to pi over 4. Again, that puts us on the pi over 4 line, which runs from here to here. And now we want the radius value to be less than or equal to 0. And so this is going to be a ray, starting with a radius of 0 and going out indefinitely from there. That's what the graph of that one looks like. And then let's see what else we got. Theta between 2 pi over 3 and 5 pi over 6. There's no restrictions on the radius, so the radius could be positive or negative. 2 pi over 3 is, 2 pi over 3 is is this line here, and 5 pi over 6 is this line here, and so any values between those are going to be part of our graph. And so this goes out indefinitely in both directions, and that's what that graph looks like. Alright, that's where we're going to stop for this video. Come back next time for examples 3 and 4 from this lesson on graphing polar coordinates and polar coordinate graphs. Alright, see you then. Have a great rest of your day.